Good afternoon to Alpha. Sound check. Can you hear me? Somebody please respond.
And
Okay, Wei Xiang, thank you. Sound check, sound check. Okay, nice. Okay, test number 2. Can you see my display? Can you
Can.
screen sharing? Yahui, thank you very much. And I hope all of you also can hear my voice clearly and see, able to see my screen sharing. Yeah. Okay, very good. Now, okay, before we start, yesterday I asked you to do exercise on your workbook page. Page 92 to 93 on your workbook. We are talking about magnetism. Okay, do you have any question regarding the exercise that I gave you yesterday? Page 92 and 93 on your workbook. Any problem? Page 90, excuse me, 92, yeah, page 92 and 93 workbook. Any problem, class? I'm waiting for your response. If you have any. One Mantai, no problem. Okay, how about the rest of you? Mantai, you are representing all your friends or no? Okay, all right. Never mind. I just do some quick review about the yesterday that I gave you exercise that I gave you yesterday. All right. Can you see my presentation? Can?
Can.
Okay, very good.
Can.
All right, thank you very much for your response. So these are the answer lah, yeah. So in your observation, actually you need to draw the magnetic field lines by using various type of magnet over here. Okay, make sure on your workbook you're able to draw the line. Maybe if you just draw a few lines also can. Okay. This is one of type of the magnet that you use. Okay, you just use a usual normal magnet bar, and then make sure also you draw the line with it what we call with it direction. Okay, mainly if you still remember, okay, the magnetic field line starting from north, coming out from the north and then coming into the south. Okay, if I able to try to draw another line over here. Okay, for example, don't forget to draw the line, yeah, to draw the magnetic arrow, the direction of the magnet over here. Okay, if I draw another one over here, starting from south. Okay, so the direction of the magnetic is always starting from north. Okay, from north, and then we'll enter the south. Okay, can you understand this, class? Make sure you're able to draw. Okay, very good. Thank you for your response. Make sure you're able to draw the direction of the magnetic field line. Okay, A, magnet bar, right? So next one, B, by using magnet. These are the answer, right? Sorry. Okay, these are the answer if you are using, you want to find the magnetic field line by using compass. Okay, just draw the direction of the arrow inside the compass here. Okay, always, again, yeah, again, it is always okay, again, it is always starting from the north. Okay, from the north over here, right, and then going enter to the south. Okay, this is the magnetic line or the magnetic field. Magnetic field line of the magnet. Okay, right. So I go to number 3. This is the U shape or horseshoe magnet. Right, horseshoe magnet. Okay, again, it has a different shape from the magnet. A different shape from the usual bar magnet. If you can see here, these are the south. Right, this is the south, and then this is the north. Okay, this is north. Again, what happened when you what we call a different different polarity? What happened to the magnet when there is a different polarity? Attract or repel. For example, here south and north here. Yeah? South and north here are close together.
Attract.
Okay, attract or repel? Yes, correct. It will attract. So how do you want to draw the magnetic field when there is an attraction? You just draw it like this. Just draw it like this. Eh? For example, you have another, if I can draw here, another piece of magnet. This is south, and then this is north. Okay, and then I just use the blue line over here. Just draw it like this, meaning that it is attracting to one another. So how about the arrow? Make sure you remember starting from north and then go to the south. So the arrow will be like this. Okay, the arrow will be like this. Okay, it means what happened here mean the magnetic force is attracting. Okay, with attracting because it has different polarity. Different polarity, it will attract. Okay, so you draw like this line. You can draw the magnetic field line like this. This is what we call a horseshoe magnet. Okay, class? Right, next one, D. D is very simple. All right, this one is very simple. You just draw a line from north to the south, meaning that the magnet actually will be attracted to each other. Okay, what happened if you try if what we call if we have same polarity, for example, north and north, south and south, what happened?
Repel.
Okay, very good. It will repel. So how do you want to draw the repel? What we call the repel. Wait, How do you want to draw the repel? The repel type. Wait a minute. What happened to here? Okay, where is the drawing? Right. For example, right here. Okay. This one is first magnet bar. And then this is the second magnet bar. This is the first one. And then this is the second one. Okay, one is south, one is north, and this also north, and this is also south. How you want to draw the magnetic field lines? It will repel, right? It will repel or attract?
Repel.
It will repel, right? So how do you want to draw the magnetic line over here? So you must remember the magnetic line is always from north to south, right? So how do you want to draw this? By using one line. So first, maybe like this lah. It's just repelling. Okay, this one also just like this. From north, right? So you must draw the arrow like this. Sorry. Then for another one, this one also from the north, and then we'll go to the south. Okay. Do you notice there is no crossing? Yeah, there is no crossing, and then there is no meeting. There is no meeting between the lines, right? There is no meeting between the line. Another one here. Then this one. Also, it will repel. It will not cross. Okay, it will not cross. Okay, it will not cross. If what? If a different polarity. Okay. If same polarity, sorry, it's different polarity like this, we have magnet bar also. North, south. And then this is south and north. So how you want to draw it? It will attract. Okay. How do you want to draw it? The attraction. What is the arrow? From north to south, right? So the arrow will be like this. And then this one will be like this. Is it correct, class? Is it correct?
Yes.
Okay. Okay, and then for the other magnetic field line, we just draw it like this. Then this one also goes like this. From north to south. Okay? Can you understand? Make sure you're able to draw the magnetic field lines here, and then make sure also you're able to identify which area has the highest or the strongest magnetic field force and which area has the lowest. Okay, for example, if I can try to use the pen over here, which one is the highest magnetic force? In A, can you see the A or B? Which one has the highest one? A or B? A
A.
or B? Okay, good. A has the highest or the strongest magnetic field. B has the lowest or the weakest magnetic field because of what? Because of the what we call that? The distance between the two magnetic line. If the distance is nearer or the distance is closer, so we can say that the magnetic force is higher. Okay, this one, if you can see here, the magnetic line is further away. We can say that the magnetic field force is weaker. Okay, class? Right? Okay. Next one. All right, discussion on page 73. Sorry, page 93. Okay, what is the magnetic field? The area around a magnet where a magnetic force can be detected. So this is what the definition of magnetic field. Okay, the area around the magnet where the magnetic force can be detected. Number 2, what form a magnetic field? You can write there magnetic field line. Okay. Number 3, state the direction of magnetic field. Please remember, always from north to south. Okay, north pole to south pole. Okay, this is the direction of the magnetic field. Okay, next one, number 4, the characteristic of magnetic field line. Okay, number 1, do not meet or cross, and then the second one, same pole repel, different pole attract. Okay, B is wrong lah, because the magnetic field one start from where? South or north first? Start from south or north?
No.
Okay, it will start from north, not from the south. So 4B is wrong. Okay. Question number 5, the relationship between magnetic force and distance from the magnet, meaning that the further away the magnet, the weaker the magnetic force, right? Okay, number 6, the relationship between the magnetic field line and the strength of the magnet. The closer the magnetic field lines, the stronger the magnetic field. Okay, simple, huh? Number 7, the relationship between the direction of the compass pointer and the direction of the magnetic field. The direction of compass pointer or needle show the direction of the magnetic field line. Okay, and then number 8, device use magnet, of course, compass, door holder. Inside we have door holder, and then not for doorknob. Doorknob is not a device that use magnet. Okay, conclusion. A magnetic field consists of magnetic field lines, and then the direction of the magnetic field can be determined by using a compass. Okay. Okay, class, never mind. After this, you can watch again the video recording after this. So today I will try to finish 7.3 magnetism. So today topic we are going to continue the last topic for 7.3. We call it electromagnet. Okay, electromagnet. Can you see my presentation, class?
Can.
Okay, right, good. Thank you very much. So electromagnet. 250. Okay, what is the difference between magnet and electromagnet? What are the difference you think? Okay, this is electromagnet. Magnet is magnet lah, yeah. We already learned about magnet. Okay, by using a magnet bar. For example, this one we have north and we have south. Okay, we also already learned their characteristic and then the magnetic field line and everything about magnet. So electro mean, what is electro mean here, class? Electro mean what? Anybody can tell me what is electro mean? What is electro? We are using what? Anybody? Hello? Electro mean?
Negative.
Electro, negative. Electro mean we use, what is this? We use?
Magnet.
Yes, we use electric. Okay. The magnet that we use before, using electric or not to create a magnetic field? Use magnet or no? Use electric or no? Wait, I will show you magnet. Okay, this type of magnet. Okay, this type of magnet that I showed you yesterday, right? This type of magnet. Okay, use electric or do not use electric in order to create magnetic field. One mantai, yes. This type of magnet, mantai, correct, does not need electricity in order to create the magnetic force. This is what we call by permanent magnet. Okay, class, this is what we call permanent magnet. This is permanent. Permanent magnet. Okay. The bar itself, the bar around the magnet itself is magnetic. Okay. It's already magnetic. It can produce its own magnetic field line. It can produce its own magnetic force. This is what we call permanent magnet. We no need electricity. No need electric in order to create magnetic force or magnetic field. Okay, this is permanent magnet. You understand this, class? Right? Okay. And then what is the electromagnet? We go back to the textbook. Okay, go back to the textbook. Oh. Okay. Electromagnet use electricity in order to create what? In order to create magnetic force, it need electric. Okay, very simple. I hope you can see the video first. I want to show you the video in order to make you more understand. Okay, this is how we can create electromagnet by just using what? Can you hear the voice? Can you hear the sound? Can you hear the sound or no? No sound, yeah? But never mind. Okay. Okay, what you need here is a copper wire, a battery, and iron nail. Okay. Before this, okay, before the experiment, the iron nail over here, class, is it magnetic or not magnetic? Magnet or no? One mantai, yes, it is not magnetic, yeah. So this experiment or this activity, we want to make the iron nail here become magnetic. So how we want to make it magnetic? We are using the battery because battery will supply the electric. Okay, battery will supply the electric. So the aim for the activity is we want to magnetize or we want to make the iron nail magnetic. Okay, before this, it is not magnetic. So what you need, a copper wire, a battery for supply the electricity, and then the iron nail. Okay, so I will continue. Just watch the video first, yeah? Okay, class. So what does how we want to make it magnetic? So first, we need to coil the copper wire here. This is the copper wire. Yeah? This is the copper wire. We need to coil it around the iron nail. Iron nail. Okay. And then before we connect it to the battery, the iron nail here is magnetized, got the magnetic field or no magnetic field? Again, got magnet or
No.
no magnet?
No.
No magnet, yeah? Okay, very good. There is no magnet. There is no magnetic field produced in the iron nail. So if you test it with paper clip, it won't pull anything. It won't pull anything, right? So let's continue the video and see what happened when we connect both ends of the copper wire to a battery. Okay, what happened now, class? Now, it is connected, right? The copper wire over here is connected to the battery. Electric will supply to the copper wire, and then the iron nail here become magnetized. Okay, it will become magnetized that it will able to pull or able to attract other iron as well. So this is what we call by electromagnetic, meaning that we want to magnetize the object by using electricity. So if you cut the electric supply, what happened to the nail? It will not become magnetic anymore. It will not attract. Okay, can you understand this, class? Can you understand what is electromagnet? I
Can.
think you can do. I think you can do the experiment, the activity yourself at home. Okay, to study, to create what we call electromagnet. Okay, right. Okay, we continue. Uh, electromagnet meaning that it is type of magnet that has temporary magnetic effect when electric current flow through it. When there is a electric current, it will be magnetic. If there is no electric current, it will not be magnet. Simple as that, right? Okay. So what is the pattern of the magnetic field? Depend on the shape of the conductor used. For example, you must remember this, yeah? You must remember this. The direction of the current up, so the direction of the magnetic field will be around the what we call the copper wire. So this is what we call a right hand grip rule. You must remember this. This is how you want to draw the magnetic field line in electromagnet, depending on the direction of the current. If the direction of the current goes up, meaning that thumbs up, and then the rest of your finger is around the copper wire like this. Okay, this is what we call the right hand grip rule. Okay, this is how you want to determine the magnetic field line of electromagnet. Okay, class? Okay. When we have the time, I don't know lah, whether we have the time or not. I will show you when we go back to the school lah, yeah? But you must understand this first. Okay. There is an experiment actually here, yeah, but I just tell you the theory first lah, yeah. Right. Mm, okay. Okay, never mind. You must understand the right hand, what we call right hand grip rule. Right hand grip rules over here. Okay, depending on the direction of the current. Right. So this is the what we call the um, the direction of the magnetic field in electromagnet. Okay. This is the example, the example of how we want to detect the magnetic field by using electromagnet. Okay. Okay. Do you have any question?
No.
Do you understand how to draw the direction? Sorry. Do you understand how to draw magnetic field line in electromagnet? Make sure you know. Make sure you understand by using right hand grip rule. Right hand grip rule, for example, like this. Okay. Because this, for example, I just draw you. These are the electric cable lah. These are the what we call the copper wire. For example, I'm using the copper wire. Okay, and then the direction of the current is from up here. For example, the direction of current is up. This is the direction of current. Okay, the direction of current is up here. So how do you want to draw the magnetic field line? You just use hand, right what? Right hand grip rule. Okay, meaning that if the right hand grip rule is like this, I just draw the finger lah. Okay, okay, all right. If the right hand grip rule is like this, meaning that the magnetic field line that that what we call um, what we call the magnetic field line form is like this. Okay, what are the direction? Like this. Okay, meaning that this is the direction of the current up, the direction of current, direction of current. Okay, and then these are the direction of, this is the direction of magnetic field. Can you understand this? Okay, can you understand this, class? This
Yes.
is how you, okay, very good. This is how you draw magnetic field line in electromagnet. Okay, all right. And then make sure the copper wire actually must be connected to what? I'm sorry for my drawing. Sorry for my drawing is not very, very nice today. Okay, all right. Okay, must be connected to what? Must be connected to battery lah or any power supply. Okay. What is the direction of the current, class? From negative to positive or from positive to negative? Please, somebody help me. What is the direction of the current? Negative to positive or positive to negative?
Negative to positive.
Okay, good. Negative to positive, meaning that if the direction of the current, if the the direction of the current is up here, meaning down here will be like this. Is it correct? Is it correct?
Yes.
Correct, huh? Because the direction of the current, direction of current is from negative to positive. Okay, so this is battery, right? Do you still remember the symbol of battery? This is positive, positive or anode, and then this is negative, negative or cathode. Okay, if I switch on, not switch on, if I opposite the battery, so the direction of current will be down here. Okay, so the direction of magnetic field also different. Okay, class? Can you understand this? Make sure you understand this, huh? All right. Okay, see, direction of the current. Make sure you always see the direction of the current. Then you use the right hand grip rule over here. Up the direction of the current, and then the rest of your finger, meaning that how you want to draw the direction of the magnetic field line. This is for electromagnet. Okay, never mind. So, do you have any question before I stop here?
No.
No question, yeah? Okay. All right. So later on, I will try to give you exercise for you to do at home. If you have any question, you can ask me later in our Telegram group. Tomorrow we're supposed to have class, but tomorrow I just give you exercise because I need to go to take my second dose of vaccine tomorrow. So tomorrow we do not have online class. No online class for tomorrow. I just give you some, maybe a little exercise for you to do at home. Yeah, class. Yeah. Tomorrow is Wednesday. No online class. Yeah, there is no online class tomorrow. Okay. Any information, latest information, I will also try to give you on our Telegram group also. Okay, class? So if you have nothing to ask, I think we end our online class for today. Thank you for your focus, patience, and attention. You can leave the class right now. Bye-bye. Thank you very much.
Thank you, teacher.
Thank you very much. Bye-bye.